All right, we are talking about bell work today. This bell work definitely leads us into what we need to talk about today, which is the unit circle. Okay, and we're going to explain things a little bit better. This first section is just what we did on our notes, so it shouldn't be too bad. On number 1 here, Jack, what'd you get for your angle on that first one? 350 degrees. How'd you get that? 270 plus 80. Good answer. This is 270 degrees. He took 80, added it to it. Boom, got it. Okay, my last class, someone said something different, but that works perfectly well because 270 would be 3 parts. My next one is pi over 4. If we start in radians, let's end in radians just because. But let's look at it. Haley, what'd you do there on that one?
So my answer's in degrees, but
okay.
When you pi over 4 is 45 degrees.
Okay.
And then since we're going clockwise, it'd be negative angle, so I just did negative 90.
Good. It's a negative angle. It's 180 degrees all the way to here, and it's 45 extra. So she said it's negative 135 degrees. That works fine. If this is pi over 4, how many is that going all the way around in radians if I went all the way to, or halfway around? That would be pi. So if I took out a pi over 4, what would this be in radians? 3 pi over 4. Negative because we're going clockwise. Negative 3 pi over 4 is the same thing as negative 135. If you wrote negative 135, you're not wrong. Just a different way of saying it. My next one here. Kara, what do you do for that one? What do you say? Yep. So this is 170 degrees. It'd be 180 degrees if we all went all the way around. That was 10. So my final answer is 370 because it's 360 degrees plus 10 more, and we were going counterclockwise, so it's positive angle. Good. That's 370. Last one. Somebody want to take a shot at that one? Yep. Lydia, what you got? Mm-hmm. If we went around the, let's stay in radians, but yes, you're totally correct. How many radians would that be if I went around the circle twice? 4 pi, because 1 times 2 pi, another time is 4 pi, so 720 degrees or 4 pi to go around 2 times. And would that be positive or negative here? Negative, because we are going clockwise here. So that's doing this. 1, 2 would get me to there, and then what else would you have to do? Okay, so what is pi over 3 in degrees? It is 60 degrees. So it's negative 720 minus 60 degrees more, and it is minus because I'm going down more. So that's negative 780 degrees. If we went into radians, we said it is negative 4 pi and then minus pi over 3 more. So we get common denominators, 12 pi over 3, and then a negative pi over 3. My answer is 13/3. Makes sense on dealing with angles there? Not too crazy, I hope. All right, now let's get into this. We are trying to find the missing side C. The blue side is 3/5, 4/5, and then C. We have a right triangle. We are trying to find a side on that right triangle. What are we going to use? Pythagorean theorem. So we could go a squared plus b squared equals c squared. A squared is, well, let's call it 3/5. B squared is 4/5. It's going to be c squared. 3 squared is 9 over 25 plus 16 over 25 equals c squared. 9 plus 16 is 25 over 25 is c squared. 25 over 25 is 1. So what's c going to be?
1.
C is 1. And that happens quite a bit, that your hypotenuse is 1. That's fine. Now we're going to get in this trig. Okay, we're going to talk about sine, cosine, tangent. You might be good at it. You might not remember it at all. Okay, whatever place you stand is perfectly fine. Just be able to learn what we're talking about today. So the best way to remember what sine, cosine, and tangent are, if you are just dealing with right triangles, is the phrase so, ka, tova. And if I'm dealing with cosine, which one of those 3 parts would be cosine? The middle part, cosine. The CAH. What that means, that's like a quick abbreviation to remind you. that cosine of an angle is equal to A over H. And in this case, A is going to stand for the adjacent side, and H is going to stand for the hypotenuse. It is always cosine of an angle. You never just have cosine by itself. It's cosine with a number. In this case, the angle is our missing thing. And so here is my angle. When we talk about adjacent, opposite, and hypotenuse, it is from the perspective of that angle. The first thing you always want to do is identify the hypotenuse, and that's the easiest one. Which one of these sides is going to be the hypotenuse? C. C is the hypotenuse. I know that because it is across from the right angle. Now we need to identify which one is the adjacent and which one is the opposite. What does the word adjacent mean? Next to. It means next to. So this is, the hypotenuse is next to it, but it's the hypotenuse, so it's not that one. This one is the adjacent side, and that makes this one over here the opposite side. So if I'm doing cosine of theta equals the adjacent 4/5 divided by my hypotenuse, divide by 1. Is it kind of dumb to write divided by 1? And so I'm not going to write it. It is 4/5. If I did tangent of theta, if I'm looking at, tangent is TOA. So that means tangent of theta equals what? Opposite over adjacent. Yeah, you're right. So opposite side is 3/5 divided by the adjacent side, which is 4/5. Ooh, yucky. I've got a fraction divided by a fraction. We can deal with it. What happens if you divide by a fraction? What are you really doing? Multiply by the reciprocal. Notice that the 5s don't matter. If you're dividing two things and their denominators are the same, we don't even really look at the denominators. We just look at the numerators. So my answer here is 3/4. Okay. We could have looked right here again and just said, oh, it's the opposite over the adjacent. It's the two numerators really being divided if the denominators are the same. 3/4. Kind of makes sense with that. That is exactly where we're headed today. So that's an important concept. All right. Today, we are not getting super deep into stuff today. Today's pretty base level stuff. But it is super important for everything we're doing the rest of this year. Okay, or at least the rest of the trigonometry, because it's really going to lay that foundation. It is going to take you some time to get better acquainted with this. At first explanation of this stuff, your brain is going to be a little bit crazy. It's okay. Okay? If you don't understand why it works, ask questions, but learn how to do the process, even if you don't understand why it is what it is. All right, so today we're talking about our 6 trig functions. That's going to be our main focus. Sine, cosine, tangent, cosecant, secant, and cotangent. Okay, you will never see it written out in words like this. Okay, from here on out, instead of seeing S-I-N-E, you will just see S-I-N. That is the symbol for it. Okay, please call it sine. It is not sin. If you say sin, we know you're not good at math. Okay, so don't do that. Sine means that's sine. Okay, that is sine. To do all of these things, just like we talked about in bell work, we are thinking about the phrase so, ka, toa. So if we're talking about sine, and I'm talking about their definition, which one of those things goes with sine? So, OH, which is going to stand for the opposite over the hypotenuse. And then I gave you a little diagram right here. Okay, this is how we're going to deal with this. The angle that we want is the one closest to the axes. So this right here is going to be theta. This side right here is obviously 5. This side here is obviously 12 because it's the ordered pair. What would I do to find the third side? A squared, B squared, C squared. Anybody know what 5 and 12 get you for your third one? 13. That is a Pythagorean triple. Memorizing that makes your life easier. But you can always do Pythagorean theorem. You don't have to memorize it, but 5, 12, 13 is something you could know. Great. Once we've done that, okay, we can do the value. So value in this case means the opposite over the hypotenuse. So from this angle right here, which one of these sides is the hypotenuse? I said hypotenuse, silly goose. It's 13. It's the hypotenuse, the one across from the right angle. And then we're doing opposite over hypotenuse. So what is the opposite side going to be? 12. That makes this guy down here the adjacent. But it's opposite over hypotenuse. It is 12 over 13. Done. Probably the most important, or the newest and thing that's going to be the most important from here on out is this last column, the definition with x, y, and r. And we will come back to that here in a second. Okay, but that is probably the most important section of this today. Let's go to our next one. It's cosine. Okay, again, don't call it cos. That's weird. It's cosine. Okay. If I'm doing cosine, we're looking at this guy right here. Cosine means adjacent over hypotenuse. Fill in the other rest of the information with cosine and tangent with your neighbor. Go. Aaron H, what do you say for cosine here? Yep, adjacent over hypotenuse. So she said that is 5 over 13. Wonderful. Matthew, what do you say? What is the meaning of tangent? What does tangent mean? Opposite over adjacent. Good. And what is opposite over adjacent according to our picture? 12/5. Great. We've got our setup. Okay. Now we're going to talk about a definition with x, y, and r. And the weirdest thing about all of this is we just talked about triangles. Okay. But trigonometry, when we really describe it, trigonometry is more about circles. We keep talking about a unit circle. Why are we talking about triangles with a unit circle? Let's try to explain that. Okay. So if I have 0, that is 0 degrees right there. If you picked a dot on this circle, like right there, and you were to connect to get to that spot, you would have to go over this much. You would have to go up that much. And you could make a triangle. Now, imagine that I could draw a good triangle and that it wasn't crooked and ugly, but there's a triangle. Okay? We are going to put this in terms of x, y, and r. Okay? And again, this is my angle right here. Which one of those sides up there is going to represent the x side? The green one is the x side because I'm going over that much. No matter how you turn this thing, if you always draw it from the center, that x is going to be what side? Is it the opposite, the adjacent, or the hypotenuse? It is the adjacent side because it's right next to the angle that I want. The blue side here is going to be the what side? The y, because it's how much did I go up to get to it. I went up that much. Now, again, it's crooked because I'm bad at drawing, but it's going straight up. What side could I label that as? Is that going to be the opposite or the hypotenuse? The opposite of the angle. It's far away from it. And that leaves me with the purple side. What is it? What am I going to label the purple as? R. What does R stand for? It is the radius of this circle because I'm starting in the middle and I'm going to the outside edge. That's the radius, which we can refer to as the hypotenuse. From here on out, we will not talk about opposite, adjacent, and hypotenuse again for a long time. It is much easier to describe stuff in terms of x, y, and r. So that's how we're going to do this. So if I say sine is the opposite over the hypotenuse, sine is this 12 over 13. Well, what does that 12 represent? Is it the x, the y, or the r? The sine is the y, or the 12 is the y, and the 13 is my r because it's my radius. This is y, this is r, this is x. So now, from here on out, every time I talk about sine, sine is y over r. I'm going to say that every day. Sine is y over r, sine of theta. Cosine of theta is adjacent over hypotenuse. Or in terms of x, y, and r, what is cosine going to be? X over r. X over r. And tangent is opposite over adjacent. So if we're talking about tangent, that is going to be y over x. Kind of makes sense where x, y, and r come from. If it's strange to you, memorize it anyways. Okay, because we're going to need that. So once we've done those setups, then the next one is easy. Okay? When we talk about sine, sine is these three on the bottom are all reciprocal functions. The reciprocal of sine is cosecant. Okay? The reciprocal of sine is cosecant. And so we abbreviate that with CSC. That is what cosecant means. We could do these definitions with opposite, adjacent, hypotenuse. Don't worry about it. It's not worth our time. We could easily flip them, but it's not worth our time. If we know that sine is 12/13, what is cosecant going to be? 13/12. If we know that sine is y over r, cosecant is r over y. My next one is cosine. The reciprocal of cosine is secant. S-E-C. Secant. If cosine is 5/13, secant is going to be 13/5. And if cosine is x over r, secant is going to be r over x. Last one. I got tangent. The reciprocal of tangent is obviously going to be cotangent. C-O-T. Instead of 12/5, it's 5/12. Instead of y over x, it's x over y. Next Wednesday, you are taking a unit circle quiz. You need to have this and this memorized. These two things need to be memorized. Okay, you got to have those locked down in order to do well. Okay, let me show you some memorization tricks. Okay, memorization tricks. Here are a few of them. Notice that sine starts with an S and its buddy starts with a C. S goes with C. Cosine starts with a C and its buddy starts with an S. C goes with S. They don't go together. So don't put C's with C's and S's with S's. That's not how it works. Okay, cosine goes with secant, sine goes with cosecant. Sine and cosine are the two that we deal with the most. They're going to deal with x and y, both over r. So x over r, y over r. Which one of those two comes first alphabetically, sine or cosine? Cosine comes first alphabetically. Which letter comes first, x or y? X. So since cosine comes first, it goes with the letter that comes first alphabetically, which is x. Do you need to memorize it that way? No, but it's helpful to do. Okay. Then notice our other one is tangent. Okay. Obviously, tangent's going to go with cotangent. Okay. Tangent and cotangent deal with x and y. Which one of them comes first alphabetically, tangent or cotangent? Cotangent comes first alphabetically. Okay. Which letter comes first alphabetically, x or y? X. So cotangent has x on top with y on bottom. Tangent has y on top with x on bottom. Simple memorization tricks. You don't need to use them, but it helps me figure out things better. Questions there? All right, let's do one. This is kind of strange. Just stick with me. Let P be equal to this point, this ordered pair right here, where the terminal side of the angle intersects the unit circle. Find the exact values. All right, so understand what this is describing. I'm going to draw a picture. You don't necessarily have to draw this picture on your paper. Okay? Radical 3/2. That is a number. It is less than 1. So imagine that this is 1. Radical 3/2 is like an x value that goes to the right this much. Like that's radical 3/2. Negative 1/2. Which way am I going to go if I got negative 1/2? Down. So this would be 1. Negative 1/2 would be somewhere like right in there. Okay? This is negative 1/2. So this is an ordered pair on a unit circle. Okay? It's on a unit circle. So imagine that you had this big old circle going around the outside, and this is the angle that intersects. Okay, that's the angle. So we've got that, we've got this, and we've got this. It is making a little baby triangle. Okay, it is a triangle on a unit circle. That's the idea of what we're dealing with. We are going to answer questions about it. Anytime in here from now on out, If I ask you to find sine, cosine, or tangent, the easiest thing to do is going to be to first to identify what is my x, what is my y, and what is my r. Identifying x, y, and r is going to make everything a lot easier. Based off of the ordered pairs, what is my x going to be? Yeah, radical 3/2. Based off the ordered pair, what's my y going to be? Negative 1/2. Oh, I did that color coordinated. Awful. Trying to be nice and organized, and I just ruined everything. Make it red. Nope, not going to make me do it. No. Radical 3/2, negative 1/2. Then I got to find my r. What would I have to do to find my r? Pythagorean theorem, kind of. You don't even need it here. Okay, because of this phrase right here. I am on the unit circle. Being on the unit circle implies that what a unit circle is. A unit circle is a circle with a single unit radius. Okay, the radius is 1 if you're on the unit circle. So when it says that there, that I'm on the unit circle, I know automatically that my radius is just 1, which is going to make this problem a little bit easier. Everybody understand how I did x, y, and r? Once I've done that, I'm going to do each one of these values. So I'm doing sine. Sine means y over r. So if I'm doing y over r, it is negative 1/2 divided by 1. So negative 1/2 divided by 1 is negative 1/2. If I'm doing cosine, cosine means x over r. If I'm doing x over r, it's radical 3/2 divided by 1. Or in other words, it is radical 3/2. Anybody so far? Tangent. Tangent means, which one goes on top with tangent? Y on top. Tangent means y over x. So if I did y over x here, it's negative 1/2 divided by radical 3/2. So I'm going to do tangent over here. So tangent of theta equals negative 1/2 divided by radical 3/2. Super yucky. Okay. So if I'm dividing by a fraction, what does that mean I'm really doing? Multiplying by the reciprocal. Or notice that when you do this, the 2's are always going to cancel. Okay, so we could have gone back to the beginning. Since I'm doing this thing divided by that thing and the denominators are the same, we can just look at the numerators. It's going to be negative 1 divided by radical 3. That's one less thing I got to do. It's just the numerator divided by that numerator since the denominators are the same, which makes it a little bit better. But I cannot leave my answer like this. We can't leave radicals in our denominator. Okay, so we have to do something called rationalizing the denominator. Anybody remember how to do that? Haley, what do I got to do?
Multiply the top and bottom by
Yeah, if I multiply both the top and bottom by radical 3, I'm not changing anything because it's like I'm multiplying by 1 because radical 3 over radical 3 is 1. But if I do that, let's see what happens. Negative 1 times radical 3, that's negative radical 3. What am I going to get if I take radical 3 times radical 3? It gets me 3, no longer a fraction. Or I'm sorry, no longer a radical. Negative radical 3/3 is my answer. Kind of makes sense what I did there? Well, let's do it again. So we did sine. All right, now we got to do cosecant. We're going to do its buddy. Cosecant. It's just the reciprocal of negative 1/2. So the reciprocal of negative 1/2 is negative 2. I just flipped it. Okay, or you could do r over y and figure out some different things. It's negative 2. Cosine, x over r. Okay, so I want to flip that. It's r over x. So if I flip that, I would get 2 over radical 3. So if I'm doing cosecant here, I'm sorry, secant here. Secant of theta is the reciprocal here, 2 over radical 3. So if I do that, I can't leave it. I got to multiply top and bottom by radical 3. So on top, I'm going to get 2 radical 3. On bottom, I'm just going to get 3. So I get 2 radical 3 all over 3. Last one is tangent. And the first thing you'll want to do is flip it. What happens if I flip tangent here? There's going to be a radical on bottom again. And you could do that and then simplify. But think about what cotangent is here. Not tangent, sorry. Cotangent here. Cotangent. It is x over y. And so if I'm doing x over y, it is really just radical 3 divided by negative 1. Now I don't have to mess with rationalizing the denominator. Cotangent is just going to be negative radical 3. Again, it's weird. I know at first glance when you do those problems, you're like, I'm writing down things that I don't understand. You'll get better as we go. Right now, you just write down things that you don't understand. It's okay. We'll get better at it as we go. Question so far? Let's try that concept again. Let P be equal to this ordered pair right here. It's the point of the terminal side that intersects the unit circle. Find the exact values of each. So again, the first thing we're going to do is do x, y, and r. My x is negative radical 2 all over 2. My y is negative radical 2 all over 2. What do you think my radius is going to be? 1. I'm on the unit circle. Fill in the table. Go. All right, here we go. We're doing sine. If I'm doing sine here, Megan K., what'd you find for sine? Yep, just negative square root of 2 over 2 because it's y over r. It's divided by 1, so we just leave it. Okay, then we're doing cosine. If we're doing cosine here, Sam P., what'd you find for cosine? Yep, negative radical 2 over 2 because it's just this thing divided by 1, so yep, we're good. If we are doing tangent, a little bit stranger, if I'm doing tangent here, y over x. So Megan Copeland, what'd you do for that one? So negative radical 2 over 2 divided by negative radical 2 over 2. Again, we talked about just a second ago, if the denominators are the same, that we could just worry about the top. And what happens if I put the same thing on top and bottom? It's 1. It's positive 1. Everybody good there? Let's do cosecant. If we're doing cosecant, it is r over y. So again, hopefully you've realized if it's r over y and my radius is 1, it's really just flipping my y. And so it is it is 2 over negative radical 2. We don't like that. So Ella, what do I need to do? We need to rationalize the denominator because we don't want radical 2 on bottom. So what does that mean? Multiply top and bottom by radical 2. So what am I going to be left on top with? And what am I going to be left with on bottom? Well, I'm multiplying. It's radical 2 times radical 2. So that's like square root of 2 squared. So those two things are canceling. It is negative 2. You could think of it as square root of 4 as well, which would get me 2. Once I've done that, now I can cancel. I've got a 2 on top and a 2 on bottom. Those two things cancel. My answer is just negative square root of 2. That's all I have left over. And if that's what sine or secant is, cosecant, then secant's going to be the same thing because I'm flipping the same thing. It's going to be negative square root of 2. Cotangent, what's the reciprocal of 1? 1. Boom, did that one. Okay. It's kind of strange. You'll get better at it as we go. We're going to have a lot of practice with it. If there's something that I would look at, okay, is making sure you are starting to memorize sine, cosine, tangent, secant, cosecant, cotangent.